Hello everyone, my name is Shahruh and I welcome you to a new DLC tutorial. In this tutorial, we're going to talk about simplification and Min SOP. So consider you're given this function and your task is to use algebraic manipulation to find the minimum product of sums. So in this case, you have to consider similar expressions. But what I mean is that, for example, here x1 plus x2 and here also x1 plus x2. So we're going to consider these two brackets. Here we have x2 bar plus x3, here x2 bar x3. So let me consider now this first two brackets or two expressions separately. Have this one multiplied x1 plus x2 plus x3 bar, this one. Okay, so now let's open the brackets, but before doing that, let's denote that this x1 plus x3 is going to be a, this a, and x3 is going to be b, x3 bar is going to be b bar. So then we consider what? A plus b multiplied, this is going to be and, right? And plus b bar. So let's consider this separately. A plus b multiplied a plus b bar. Let's open the brackets. What I do is I multiply a to this, b to this, and b to this. A simple way of opening the brackets, right? So what I have now, a multiplied to a multiplied to b, right? Plus a multiplied b bar and b multiplied to b bar. So a multiplied to a is going to be always a, because you know this is an AND operation. I mean, if a is 1, so 1 and 1 is always 1, and if a is 0, 0 and 0 is going to be 0. So that's right. Let me write here result of it. Here 1 a plus this a multiplied b stays the same, and a multiplied to b bar stays the same, and here d multiplied to b bar, b and b bar is always 0, because you know if b is 1, b bar is 0, so this 0. If b is 0, b bar is 1, this is 0, right? So that's why we kind of omit this. Yeah, you kind of do like this. So there's now b multiplied b bar. So overall, what we have, we're going to move this a out of the bracket. Then we have 1, right? A is moving outside the bracket. So b plus b bar. I mean, here we have this 1, here is b, here is b bar. So you know, this is plus, this is going to be OR operator. And even so this b or b bar are 0, let's say, there's always 1, right? So that's why the result from this bracket is going to be always 1. So overall, what we have left is just a. So what does it mean? A was what? x1 plus x2. This means the result of the multiplication of this bracket or this expression is going to be just x1 plus x2. Okay, so if we consider the second two brackets, I mean here x1, this one, this bracket and this bracket, what happened? x1 plus x2 plus x3 multiplied x1 bar, x2 bar plus x3. Here, as you see, x2 bar and x3 is going to be a, x2 bar x3 is going to be a, x1 is going to be b, and x1 bar is going to be b bar. So we know that this is going to be what? Let's change the position of these two values. So variables, the sum is not changed, right? So multiply it a plus b bar. So we do know that the result is a, and the result is a was what? x2 bar plus x3. Okay, so the final result is going to be what? the final result, oh, let me write this in black. So the final result is going to be x1 plus x2. This is from the first two brackets, I mean from this, and multiplied to this, x2 bar plus x3. I hope it was pretty understandable for you, right? The very first thing is to identify the common expressions, or let's say similar expressions. Once you identify the similar expression inside the expression, in this case this is going to be this x1, this and this, then you perform this algebraic manipulation. I mean, you open the brackets most of the case and you see the common behavior. And for simplicity, I do recommend you to denote the common expressions, I mean x1 plus x3 or x2, as another variables, so that your life becomes easier. So now let's consider another task. In this task, you're given what? You're given this function, in this case with 3 inputs, and you're given this sum of products, Min SOP. You're already given the Min SOP. So yeah, in this task, your objective is to design the simplest sum of products circuit. So you have to here implement this function with what? Logical gates, right? Or logical gates or operators, let's say, yeah, operators. So the very first thing is to understand that. Let's write this sigma, or I don't know, sigma M3, M4, M6, and 7 are going to be what? The sum of M3 plus M4, M6, and M7. Okay, and for this you have to understand that there are 8 set of inputs. So for this you have to consider the truth table. So what I mean by this is that there are 3 inputs, right? x1, x2, x3, and there is the output, right? So we are taking as the ratio starts from the 0, right? 1, 2, 3, 4, 5, 6, 7. And why we are taking M3, M4, M6, and 7? This is because at this rows, the output F is 1. So this is called the Min SOP. In Min SOP, you take the row where the output is 1. So M3 means here we have 1, M4 means here we have 1, M6 means here we have 1, M7 means here we have 1. Sorry for the noise around. So at M3 we have what? We have the value of x1 0, x2 1, x3 1. Yeah. Let's start from this here. 0 0 0. I'm doing this basic stuff, 0 0 1. I guess 1 0 1 0. And here 1 0 0, 1 0 1, 0 0 0. Yeah, here. So we are taking here we have zeros. Here we have zeros. Here we have 1. We are taking only rows where the function's value is 1, right? So this is a phenomenon of Min SOP. In max term, or let's say, you only take the rows where the value is 0. So we're taking here the 1, okay? So let's represent this M3. What does it mean in M3? Let's say M3 means just the multiplication and operation of the inputs. So x1 and x2 and x3, right? So x1 is what? 0. So that's why I put this bar. x2 is 1, x3 is 1. So overall, instead of this and, I can write this dot, right, to make our life easier. So this is, yeah, this is how we write M3. So as you guess, M4 is going to be what? X1 is 1, so x1, x2 is 0, so x2 bar, and x3 bar, because this is AND, right? So because here we have 0. So, and so on. So let me write this as the same, just the final version. So x1 bar, x2, x3 plus x1, x2 bar, x3 bar plus x1, yeah, here, x1, x2, x3 bar, okay? Plus x1, x2, x3, because at the 7th row, we have only the values of 1. So now the steps are very easy. So, you know, you can do, of course, implementation of this function, just leaving the function in the sys format, but our objective is to simplify this function to make our life easier, okay? So let's start simplifying. What do we do is to find the common behavior. So if you see that here, let me choose the next color, another color. Here, x2 and x3 are common. And here, x2, x3 are common. And here, let's say x1 and x3 bar, x1 and x3 bar. So let's consider this, let's say, a set of inputs, right? M separately. So, okay, yeah, I'm moving this x2 and x3, let's say, yeah, out of a bracket. I mean, I'm considering this now and this. I'm moving this common inputs out of the bracket, and I have this, and I left with x1 bar, this, I mean, this and this. Here, I remove x1, I mean, the next two brackets, not brackets, of course, expressions, elements, x1 and x3 bar, and I left with x2 bar plus x2, right? I mean, this, I left with this ones. And as you know, x2 plus x2 bar, yeah, let's say, is always 1, just because, you know, let's say x2 is 0. 0 plus bar of 0, not of 0, is 1. And let's say x2 is 1, not x2, let's say it's a, right? A, doesn't matter, x2 or a. If a is 1, here, 1 plus not 1 is 0, so 1. This is always 1, okay? So this is always 1. Let me remove it. That's take too much time. Okay, yeah, good. It's always 1. So that means this is 1 and this is 1. So finally, what we have left with is this x2, x3, right? This and y multiplication plus x1, x3. So yeah, I hope it's understandable, right? So we simplified from this to this. So now our objective is to implement this function. That means to draw the function with the operators, I mean, and or XOR, let's say. So let me draw it. This here, x1. Let's say here we have, let's say, x3, and here we have x2. So very first thing, x2 is multiplied to x3. So I have here what? Let's say I have here one AND operator. This is going to be AND, right? Multiplication is AND plus multiplication is AND. This is this operator. Plus is OR. This is going to be this operator, I guess. Yeah, this is OR. So here we have yeah, and this is AND, right? I mean, let's say this is one, let's say second, I mean, first operator and second operator. So this is going to be first operator, and let's say this is third operator, right? So here we have what? x3 bar, okay, x3 bar. So I need to have here inverter that makes the input inverted. If it's 1, it becomes 0, okay? So inverter, this bar. So yeah, I have here again AND operator, and my input comes here. So let me denote that is a second operator, right? And the third operator is OR. So let me draw this OR. Yeah, OR. So this is our final result, and this result equals to f equals to x2 multiplied x3 plus x2 multiplied x3 bar. So this is the end. So I hope it was pretty understandable for you. So follow us in our Telegram channel and subscribe to YouTube channel. And if you have questions, just write in the comments or just ask your questions in our website's forum. The link to the forum you will find in the description. So thank you very much.